Bismillahirrahmanirrahim. Assalamu alaikum students. How are you all? Today we are going to start our chapter 17, Networking and Communication Systems. The foundation of this chapter was developed in the second chapter of AS. You might want to review or revise that chapter in order to gain better understanding of chapter 17's concepts. So without further ado, let's start our lecture. So networking and file sharing protocols is the chapter. First of all, we need to understand about the data communication systems. A system which is transmitting data from one end to the other end. This system mainly involve 5 different components. First of which is a sender that generates the message, that needs to send the message, transmit the message. A receiver is who is going to get that message, who is the intended target of our message. A transmission medium, how are we sending that message? Maybe we are sending the message through a fiber optic cable, or maybe we are sending the message wirelessly, or maybe there is a coaxial cable. The transmission medium would be providing the means on which the message is going to travel. The message itself, the message here is a general term. We are using this word as to describe any piece of information that is being sent or received, any piece of data that is being sent or received. Then a protocol. At this time, I'm only going to tell you that a protocol is a set of rules that is used to accomplish a particular task, that we follow to accomplish a particular task in computer science. There are a lot of different protocols, different agreed upon ways of communication that we are going to study in this chapter. Uh, Especially in the networking and the internet. So these are the 5 requirements, 5 components of a data communication system that needs to be there in order for communication to happen. Now, an isolated network topology. An isolated network is something that is not connected to any other network but itself. Imagine a network that is in your home. The 4 computers are connected with each other using your Wi-Fi router. Let's exclude the possibility of internet for a moment, and then you would have an isolated network of your home, which is going to have 4 computers, and that's it. Maybe the oldest way of making an isolated network was a point-to-point network, 2 nodes joined by a single cable, and since they are joined by a single cable, they are able to communicate with each other. Then the word topology actually means the method, the technology of doing, of developing, establishing the network itself. So we have a number of different topologies. We are going to look at their structure. We are going to see how those topologies, those methods of making the network work, and what are their advantages and disadvantages. So first off is a bus topology. In bus topology, there is only one link, one common bus, which is connecting all the nodes. I would like you to pay attention to this diagram. You can see that there is a single cable, a single transmission medium, which is having terminators at the end. So the signals just bounce back from the terminator. They are the closing points of the wire, which is being used as a bus, as a common pathway of connecting all the computers. And then you can see that all the computers, all the nodes of the communication, whether they are the server, the workstation, the printer, or any other thing, that any other node which is connected to the network, they are connected to that central transmission medium, that central bus. This network can be called multi-point network. And how actually communication happens: if a computer has to send data to the other computers, the data is going to travel on the bus. Each of the computer is going to see that piece of data and trying to see that if that data is mine. If it's not, the computer will just let it pass, let it go ahead to the next one. And if that data is intended for that computer, it just picks up the data from the bus. So you can see that there is a little problems that can happen. For example, there is a larger possibility of collision. If the computer is trying to send data and the other computer is also trying to send data at the same time, they're going to see if the bus is free or not. Obviously, it is carrying less voltage if it is free, and it would be carrying more voltage if it is carrying electrical signals of data. So when two computer checks, they want to send the data. When two computer checks if the bus is free, they would both find it free. But if they send the data at the same time, the collision will happen. And we would study later on the collision detection protocol, CSMA-CD, which would dictate the computers to step back and wait for a period of time and then try again to send the data. There can be a problem of security as well, since the data passing through the bus is visible to all the nodes connecting to the bus. So if one computer is sending the data to the last node of the network, all the nodes that are in between, they are looking at the data. They can uh, see the data. That makes this network a little bit less secure. Its advantages would be that it is easy to implement, and there are adding more nodes to the network is easy. You just uh, get the terminator away, extend your bus, and add another node to your network. So it is quick and easy to set up. Since the shared medium, the single bus is common, so it might use less cabling than the topologies that we're going to study after that. So it is going to cost a little less than the other topologies. The disadvantage is that, as I told you, that the medium is shared. So if the main bus is broken, some errors have occurred in the network, so it would be difficult to locate. Obviously, we have no way of knowing which node is non-responsive or where the error have occurred. We have to go through all the network. And as we are adding more and more nodes, the performance of the network is going to be considerably reduced, because all of them will be trying to use the shared pathway of the bus, and it is a simple rule of traffic. More traffic is going to cause uh, more delays, more collisions. If the bus cable is damaged somehow, obviously the whole network is going to stop. And as I told you earlier, it is a bit less secure that all the computers actually see the data packets going through the bus to check if the packet is intended for them or not. If the packet is there, they just pick it up. If not, they just let it go. And data collisions are likely to happen. And if you are having more computers in your network, so they are more likely to happen. So since for after every collision, the computers have to stop, step back, wait, and then send the data again. To this cause network to slow down. Another way of doing things is ring topology. In ring, the computers are connected first to second, second to third, third to fourth, and fourth again to the first, causing to make a ring or a loop, as you would say, of computers. So as you can see that in this network, the data has to be sent from one node to the next node through all the nodes. And if one computer has to send message to another computer, the message or the data packet would start passing through the nodes that are in the path until it reaches from to the computer for which it was intended. And you can see the problem here, I think, that if one of the nodes is out of order, the whole network actually stops. Now, there is one advantage that since the data is going to travel in only one circular direction, there are no collisions that are likely to happen. When one computer is sending data, only that data would be sent, the other would wait. The chances of happening a collision are none. Then, if you're adding more and more computers to your ring, the bandwidth of the network is still going to remain the same. Because again, I was having four computer rings, and then I made a six computer ring, but only one computer is sending data at a time. So the whole bandwidth is available to the one computer. So uh, the network bandwidth issue will not be there. However, other computers might have to wait if the large amounts of data have to be transferred, then there might be a latency for the other computers because they would not have the chance to send their data until one transmission finishes. And the disadvantages, as I told you, if one node fails, the whole ring is going to break down and nothing is going to be transmitted. It's difficult to troubleshoot a ring network because again, if an error has occurred, you have to take your whole network offline, then troubleshoot it, then make it online. As all nodes are wired together, the network, as I told you, must be temporarily stopped or taken offline in order to add additional nodes. Another thing was mesh topology. In mesh topology configuration, each node has its own connection to all the other nodes of the network. Look at this diagram. No matter from which computer you look at this, each of them is having their own connection. For example, this computer has its own connection to this one and this and this and this. And no matter from which node you're looking at the network, each of the computers is going to have its own individual connection to all the other nodes. Now that actually means a lot of mess of the cables. And this little formula here actually tells you how many uh, connections you are going to require in order to make a network of mesh topology. If you are going to have 6 nodes, solve this equation for n is equal to 6, and then you would know that how many connections you actually need to make in order to make a mesh topology network. So each node is capable of sending and receiving messages to the other nodes. The nodes act as relays, passing on a message towards its final destination. The advantage of mesh topology would be that messages can be received more quickly if the route to the intended recipient is short. If the computers are placed closely, that messages would be quicker to move within the network. The messages would always get through because, as you have seen the diagram, a message can take one of the multiple available pathways to it. It can follow the direct pathway, it can go around the network through the computers, it can be relayed from one computer to through other computers to its destination. So ideally, no messages in this topology are lost because they have more than one possible routes to follow. Multiple connection means that no isolation of the node. There is no chance of one node is being left behind or being left out of the network. And each node can transmit to and send and receive data from more than one node at the same time. Since we have more than one connection, so that means one node can be sending data, computer 1 can be sending data to computer 3, and at the same time computer 1 is also receiving data from computer 4. This can happen simultaneously because we had separate connections. We have more than one connection, so they can be used for both sending and receiving data. And we can add another node without actually taking the whole network offline. We just need to make new connections of the new node with all the existing nodes. So network doesn't have to be switched off. Other nodes doesn't have to be switched off. Without interrupting them, we can make this. The disadvantage of mesh topology would be that a full mesh network would be impractical to set up, because if you solve the formula that I just showed you in one of the previous slide, try to solve that formula for 10, maybe 20. You would see that you will require such a number of connections that it is going to be a headache to set up that many connections and run the network. And as the number of connection increases, the need of maintaining the connection is also increases. There can be as many flaws as with as much there is the number of cables. Most of the network might be redundant. See, if you have 4 available routes to you, you're likely to use the shorter route always. You might not use the longer routes ever. The data packets behave the same way. They take the quicker routes. So most of the network might be left unused. Then we have star topology. And this one is, I think all of you are quite familiar with. The one having a central device, a hub or a switch or a router. We'll talk about the little differences in the next lecture. but all the computers are connected to that central device, and that device makes the communication happen. All the data is sent through the hub or switch, and actually that central device directs the data towards the computers. The advantage of star topology is that each node is separately connected, and therefore failure of one of the nodes or its links does not affect the other. If one computer is out of order, it doesn't affect the network at all, because network is actually relying upon the central device, not the individual nodes. New nodes can simply be added by connecting them to the switch. You just lay a cable, connect that cable to your hub or your switch, and that new node becomes part of your network. And this topology have higher performance, higher data, uh, I should say a higher bandwidth, and the messages are delivered to the intended recipient only. Not all the computers have access to the messages that are passing through the network. A disadvantage of the star is, obviously we have picked up on that one already, that if the central device is failed, the whole system breaks down. No communication is possible. Then, since each computer has to have its own dedicated connection to the star hub or switch, so that is going to cause a lot of cabling, a lot of wiring is required. And since all the computers are using the hub or switch, the central device, to transmit the data, that can create a choke point. If the large amount of data is being transmitted, a bottleneck situation is created at the central switch, which is obviously going to reduce the speed of the network. The last thing I want you to see is the hybrid technology, combining different network topologies, and getting the benefits of all of them. Although this idea seems worthwhile, it requires a lot of complexities and a lot of skill to set up this kind of network. But we can make a network by mixing two topologies, maybe a star bus topology, or maybe all of them together, whatever suits our need. The advantages of that would be that we are going to have the best feature of all of them, and disadvantages are that it is going to be expensive and it is going to be a lot complex to set up. So this was today's lecture about the network topologies and the methods of making or setting up an isolated network. I would welcome your questions and queries if you have any, and I'll see you again in the next lecture. Allah Hafiz.